Good morning everyone. Today we are going to discuss about transient response of series RC circuit for AC excitation. This is a simple circuit with RC in series. Input we are applying is Vm sin omega t, Vm sin omega, and at t is equal to 0 the switch is closed. So we will be deriving the current equation here. Current equation I of t. So if you applying KVL here, Vm sin omega t is equal to I times of I of t into R plus capacitor current we will be returning as 1 by C integration I of t dt. We know at the capacitor Vc will be C times of di by dt. Current equation, known equation is I is equal to C dVc by dt. From this, if you find the current, it will come here. So differentiating on both sides. To remove the integration, we are now differentiating on both sides. So Vm omega cos omega t is equal to di by dt times R plus 1 by C. Integration and differentiation cancel out. So I of t or I. Now dividing R on both sides, and we are writing differential equation in left side. Di by dt we divided by R, so R get cancelled out, plus 1 by RC I is equal to Vm omega by R cos omega t. This equation is look like dx by dy plus py is equal to q. And this is equation 1. This is dy by dx plus dy is equal to q. This is in the same form. For this differential equation, the solution will be y into integrating factor is equal to integration of q times of if dx plus c. So integrating factor value will be e times of p dx. This we will be discussing in differential equation topic. So to solve this type of linear differential equation, this to be followed. So first integrating factor to be derived. Here in place of p we have 1 by RC. P is equal to 1 by RC. So integrating factor will be e power integration of 1 by RC dt, that is equal to 1 by RC into t. this is integrating factor. Now we'll be placing in the solution, complete solution. Y in place of y we will be placing I of t, and integrating factor we got e power 1 by rc into t is equal to, in place of q what we have is Vm omega by r cos omega t. If is e power 1 by rc into t dt, plus c is the constant. So from this equation I of t e power 1 by rc into t is equal to this constant coming out omega by r, and integration we have formula e power 1 by rc dt cos omega t dt plus c. So we know the formula for integration e power ax cos bx into dx is equal to e power ax by a square plus b square into a cos bx plus b sin bx. By this equation we will be writing I of t e power 1 by rc into t is equal to Vm omega by r. Integration of this one is, we will be replacing this integration to here, e power ax, that is e power 1 by rc by a is 1 by rc whole square plus b is omega square. Now a value is 1 by rc cos b is omega t plus omega sin omega t plus c. Now I of t we will be taking this e power 1 by rc into t into RHS, then it will be Vm omega by r e power minus 1 by rct. This comes here, so it becomes minus, and our equation is e power 1 by rc by 1 by rc whole square plus omega square 1 by rc omega t plus omega sin omega t, plus when this comes here it will be multiplied e power minus 1 by rc t into c. So from this, in this equation, this minus 1 by rc and e plus 1 by rc into 1 by rc t will be cancelled out. So remaining will be Vm omega by r into 1 by rc whole square plus omega square into 1 by rc cos omega t plus omega sin omega t plus e power minus 1 by rc into t into c. So to make it simple equation, we are considering a sin theta is equal to 1 by rc and a cos theta is equal to omega. Then we want to replace a sin 1 by rc into a sin theta in this term, and want to replace omega. In place of omega we will be replacing a cos theta here. So from this we need to find first a and cos theta. From that impedance triangle we know that R, this is XC and Z, this is angle theta. Theta is equal, XC is equal to 1 by omega C. Tan theta is equal to tan inverse of opposite 1 by omega C into R. This is the theta value, and to find the A value, we have an identity that squaring on both sides and adding them. A sin theta whole square plus A cos theta whole square is equal to 1 by RC whole square plus omega square. From this, A square is taken common, means sin square plus cos square will be 1 if it is from an identity. Then 1 by RC whole square plus omega square. Then A will be under root of 1 by RC whole square plus omega square. This will be the A value. So with this A value we will be replacing A 1 by RC with A times of sin theta. In this we are replacing A cos theta and A sin theta. Then I of t will be Vm omega by R 1 by RC whole square plus omega square into A times of, we are replacing 1 by RC with A times of sin theta. That means A is under root of 1 by RC whole square plus omega square sin theta cos omega t, plus in place of omega under root of 1 by RC whole square plus omega square cos theta into sin omega t plus e power minus 1 by RC t into C. C is the constant. Now we are taking common 1 by RC omega. Vm by omega by R under root of 1 by RC whole square plus omega square by 1 by RC whole square plus omega square into sin theta cos omega t plus cos theta sin omega t plus e power minus 1 by RC into C. So we know sin A plus B is equal to sin A cos B plus cos A sin B. then I of t is equal to, we can write this as 1 by under root of 1 by RC whole square plus omega square. This we can written as sin omega t plus theta plus e power minus 1 by RC t into C. So further so from this equation, if we take omega square outside from root, then that omega will be cancelled with this omega, and if you multiply r inside, then the overall equation will be 1 by under root of 1 by omega c whole square plus r square is equal to sin omega t plus theta plus e power minus 1 by rc into t plus into c. If you calculate this omega r into 1 by under root of 1 by rc whole square plus omega square, then we will be obtaining this concised value. This is nothing but z. So now we need to find this constant c at I is equal to at t is equal to 0, at the instant of the time we are applying sine wave. At t equal to 0, we will take the equation, first equation, basic equation, Vm sin omega t plus is equal to I of t into r plus 1 by c integration I of t dt. In this, at t is equal to 0 instant, sin t will be 0 and I of 0 into r plus at the limits 0 to t, that is t at 0th instant, the current value for sine at the instant 0 will be 0. So at I of 0, the current is also 0. So 0 is equal to Vm under root of r square plus 1 by omega c whole square into sin theta plus e power 1 by rc into t. If 0 means e power 0 is 1, then it is c. Therefore c will be minus of Vm r square plus 1 by c whole square 1 by omega c into sin theta. This is the c value. We will be replacing this c value in the derived equation. Then overall equation will be I of t is equal to Vm under root of r square plus 1 by omega c whole square sin omega t plus theta plus e power minus 1 by rc into t minus of Vm under root of r square plus 1 by omega c whole square into sin theta. This minus will be added here, and this is overall minus. This c value will be changes at when the instant at the t instant changes. This constant c value will be changes, but this is the forcing response. This will be sustained throughout the throughout at a t tends to infinity, this will be natural response, died or died out, decaying response. Let us look at this question. In this question, at t tends to 0, the switch is closed. We need to find the I of t, current equation in this. So to find the current equation, from this equation, first one by one terms we will be finding out. Now we will be finding theta. Theta will be tan inverse of 1 by omega c into r. Here omega is omega t. Omega will be 500. C will be 100 microfarads. R will be 15 ohms. Now theta will be tan inverse of 1 by 500 into 100 micro into 15. The tan theta value will be 53.13. Now we got this value, and we need to find one Vm by under root of r square plus 1 by omega c whole square. Vm will be 100 by under root of 15 square plus 1 by omega is 500 into 100 micro whole square. Then this value will be 4. So without let, we are placing the values in the overall equation I of t. I of t will be 4 times of sine 500 t plus theta will be 53 degrees minus e power 1 by rc. The value of 1 by rc. 1 by rc means 1 by 15 into 100 times of u. Then it will be 6666.67. Then e power minus of 666.67 t into the constant value is 4 times of 4 into 0.8. Overall current equation will be 4 sine 500t plus 53.13 minus 3.2 e power minus 6666t 7 into t. This is the current equation.